Students, so we are going to see the consistency of system of linear equation by rank method. So consistency of system of linear equations, what we are going to do, we are going to check whether the system of linear equation is consistent or inconsistent. Which method we are going to follow? Rank method. So the first step is we have to write the system of equation in the matrix form Ax is equal to B. Then you have to write the augmented matrix A, B. Beside A, you have to write the elements of matrix B. And then bring the augmented matrix into echelon form. After bringing into echelon form, according to Roche-Capelli theorem, so when you are going to get the unique solution, okay, when you are going to get the unique solution, okay, so see that you have to find out row of A and you have to find out row of AB when they are equal and which is equal to n. So what is n? N is the number of unknowns. The unknowns means how many variables we have to find in that equation. Okay, what is the condition here? I am saying row of A is equal to row of AB, which is equal to n. N is nothing but the number of unknowns. Everything is, all the three are equal. We can say the system of equation is consistent and it has a unique solution. See that? Row of A is equal to row of AB is equal to number of unknowns. Then the system of equation is consistent and it has a unique solution. So we'll see the exercise problem. Exercise 1.6, the first problem. Test for consistency and if possible solve the following system of equations by rank method. Which method we are going to use? Rank method. I'll take the first subdivision problem. You see that there are three equations, okay, in this system. So what's the first step? I have said in the rank method, you have to write in the matrix form Ax is equal to B. So the coefficient matrix is written here into the XYZ matrix is equal to 2, 7, 4. Ax is equal to B. What is the second step? You have to write the augmented matrix. Look at this. The coefficients, the coefficient matrix A, I have written here beside B matrix. Which is the B matrix? You look at this, 2, 7, 4. The 2, 7, 4, the elements, how it has come. So it is the right hand side of the equation. So I have written the augmented matrix. So what is the third step? We have to bring this augmented matrix into echelon form. So what is the echelon form? 0 rows occurs below the non-zero row. Here there is no 0 rows. So what is the next form? We have to make these two elements are 0. So okay, you have to change, you have to transform R2. So here you are having 2, in R1 you are having 1. So R1 elements has to be multiplied by 2. Okay, so the transformation R2 implies R2 minus 2R1. See, therefore R2 elements is 2, 1, 4, 7. R1 elements is, what are the R1 elements? 1 minus 1, 2 into 2. So this elements has to be multiplied by 2. So it will become 2 minus 2, 2 minus 2, 4 minus 4. And in between you are having subtraction, so you have to change the sign. So you will get this answer. So I have written the answer here. And what is the next step? You have to make R3 element, the first element of R3 or is 0. Okay, so what is the transformation we have to do? We have to do the transformation in R3. You see the first element here you are having 4. In R1 the first element is 1. So R1 elements has to be multiplied by 4. So the transformation R3 implies R3 minus 4R1. You look at this, refer. R3 I have written. R1 elements, what you have to do? You have to multiply by 4. It will become 4 minus 4, 8 and 8. In between you are having subtraction, you have to change the sign. While you are simplifying, you will get this answer I have written here. Is it in echelon form? No, it is not in echelon form. Why? You comparing the second and the third row, we have to make this element as 0. Okay, because the first non-zero entry below that below that the entry should be 0. So we have to make this element as 0. So where is this element? It is in R3. So we have to do the transformation in R3. So look at your R3. Here also you are having 3. Here also in R2 also it is 3. So when you subtract, automatically it will become 0. Okay. So the transformation is R3 implies R3 minus R2. So here you see that 0 minus 0 is 0, 3 minus 3 is 0, minus 7 minus 0 is minus 7, minus 4 minus 3 is minus 7. Now it is in the echelon form. Okay, after bringing the augmented matrix into echelon form, you have to find what is row of A. How to find row of A? Row is what? It's a rank. Rank of which matrix we are going to find? A. So see that the first 3 rows except the 4th column, okay, except the 4th column, then you have to find the rank of the matrix A. You see how to find the rank of the matrix? You have to count how many non-zero rows in that. So hiding the 4th column, you have to count how many non-zero in this 3 rows. So see that, look at this, this is the first one, this is the second one, and this also a non-zero row. How many non-zero row you are having? 3 non-zero row. Okay, then you have to find the rank of the augmented matrix. Okay, so the whole thing has to be considered, and you have to find the how many non-zero rows in it. You look at this, first, second and third. So here also 3 non-zero rows. How they are? Both the ranks are equal, and you have to check number of unknowns. How many unknowns are in this equation? X, Y, Z. So there are 3 unknowns. Okay, so here you are getting in this problem, row of A is equal to row of AB is equal to 3. Okay, so see that, what is the condition I have said previously? Row of A is equal to row of AB is equal to number of unknowns. What conclusion you have to give? The system is consistent, it has unique solution. So see to that, I have written the system has a unique solution, it is consistent. Okay, but now we are going to find the unique solution. Why it's so? It is solved in this question, solve is given. But we have to find the solution. So from the echelon form, the last form, that is the echelon form, you just consider the last row. Here you are having minus 7. So minus 7 is a coefficient of Z. So minus 7 Z is equal to minus 7. From this Z is equal to 1. So go to the second row. Here it is 0. It's a coefficient of X. And you see that here also 0. It is a coefficient of Z. So Y coefficient alone is here. About 3Y which is equal to 3. So Y is equal to 1. So in the same way, go to the first row. Here you are having X and minus Y plus 2Z, that is equal to 2. X minus Y plus 2Z is equal to 2. Substitute the values of Y and Z here. Y is 1 and Z also 1. So when you substitute, you will get X plus 1 is equal to 2. X is equal to 2 minus 1, that is equal to 1. So we have found the solution. So see that row of A is equal to row of AB is equal to number of unknowns, means the system is consistent, it has a unique solution. Okay, we'll see the next solution, that is no solution. If row of A not equal to row of AB, then the system is inconsistent. Okay, and it has no solution. You look at this, row of A is not equal to row of AB. You have to write then the system is inconsistent. Okay, and it has no solution. We'll see the problem. Third subdivision, look at this. There are 3 equations. What is the first step? You have to write the system of equation in the matrix form. AX is equal to B. So this is A, this is X matrix, this is equal to B. What is the next step? You have to write the augmented matrix. Okay, so how to write the augmented matrix? First, coefficient matrix A has to be written. Beside, you have to write the B matrix. Okay, so you see that you have to bring this into echelon form. So what is the first step for the echelon form? So here we have to make these 2 elements as 0. Before that, to do the calculation easily, I have interchanged R2 and R1. Okay, so if we have 1, it is easy for it to make these two elements as 0. Okay, so I use the transformation R2 interchanged as R1 and R1 is interchanged as R2. Okay, here I have written. You see, look at this. We have to make these two elements as 0. So what transformation here you have to use? R2 implies R2 minus 2R1. Okay, so here if you make this element as 0, R3 implies R3 minus 3R1. So I have done the rough work. So here you are getting this answer. Okay, it is not in echelon form. So what you have to do, you have to make this 4 as 0. So here also 4, here also 4. So the transformation has to be done in R3. R3 implies R3 minus R2. So when you subtract, you will get this element as 0. 0 minus 0, 0. 4 minus 4, 0. Minus 1 plus 1, 0. And 1 minus 3 is equal to minus 2. Now it is in the echelon form. Okay, so you have to find the row of A. Row of A means hiding the fourth column. You have to find out how many non-zero rows are there. You look at the non-zero rows. This is the first non-zero. This is the second non-zero row. Okay, third one is a 0 row. Appa, how many non-zero rows you are having? 2. Okay, go for finding row of the augmented matrix AB. So the whole form has to be considered. The whole matrix has to be considered. Find out number of non-zero rows. So first one, second one and the third one. Here you are having minus 2. So it is equal to 3. How they are? They are not equal. If they are not equal, we have to say the system is inconsistent. It has no solution. But when you are going to obtain the no solution means row of A is not equal to row of E, row of AB, then the system is inconsistent, it has no solution. Thank you, students.